Hello, Matthews Gatos here. In this video, we're going to do part one of related rates. So I'm going to start off just by introducing you to related rates, and then I'm going to do equation type problems. And in part two of related rates, I'll do triangle type problems. So first of all, let's talk about what a related rate is. A related rate is a question that says something like this: how quickly is fill in the blank changing? How quickly is the volume changing? How quickly is the distance changing? Whatever it is, it's the fill in the blank. That's a related rate. So how quickly one variable is changing if you know how quickly another variable is changing. So some general tips here. If a formula is not given, create one from relationships in trigonometry. Look to Pythagorean theorem, volume, area, similar triangles, those types of things. Once we find out what our equation is, we're going to implicitly derive with respect to time. So implicit differentiation means we're doing it with respect to time. So that means any variable other than time will have a derivative of variable prime, or the derivative with respect to time. So I just want to review by doing a couple examples here. So say I wanted to take the derivative with respect to x. So since the derivative matches here, I'm taking the derivative with respect to x. Since it matches, and we know the derivative of x is 1, we can do this one just like normal, and it would be 3x squared, and the derivative of x is 1, so we don't really need to multiply by 1, so we can leave it as 3x squared. Now let's look at the next one. I'm taking the derivative with respect to x, but I'm doing it for y. So those don't match. So what I need to do is take the derivative. So just like x cubed, y cubed would have a derivative of 3y squared. But then I take the derivative of y. So since it's respect to x, I don't know what the derivative of y is. So I indicate that by saying y prime. Okay, now we're going to take the derivative with respect to time. So again, it does not match. So I don't know what the derivative is. So I'm going to write this as 3x squared, and then I'm taking the derivative of x with respect to time. So I'm just going to write down dx by dt. So that's the derivative of x with respect to time. Again, same thing here, time and y, they don't match. So instead of just saying y prime, because it's with respect to time, I'm going to write this as 3y squared, and then times by the derivative of y with respect to time. Okay, let's try another one. So this one here, I'm taking the derivative with respect to time, and look, I have two variables that aren't time. Now remember, when we have two variables that are multiplied together, I need to take the derivative using the product rule. So using the product rule, I'm going to do 1 and then d2. But I don't know the derivative of y with respect to time, so I will multiply it by dy by dt. So this here is 1d2. To that, I need to add 2d1. So second function times by the derivative of the first function, which would be 2x, and dx by dt. And this would be 2d1. And I'll just leave it like that for now, but you would tidy it up depending on the question. Let's look at number 6. So this is an area of a circle, and I'm taking the derivative with respect to time, and I'm doing this to both sides. So this is the first time we've had an equation. So when I take the derivative with respect to time, it's for both. So the derivative of area with respect to time is just dA by dt. Now, pi is just a constant. Pi is approximately 3.14. So I can multiply it up front. So it's going to be pi times the derivative of r squared. Now the derivative of r squared is 2r, and then since it's with respect to time, it's dr by dt. Okay, number 7, the derivative with respect to time on both sides. So the derivative of volume is dv by dt equals, And again, 1/3 and pi, those are just constants. So we can take the constant up front, which is pi over 3, and then I'm going to do the derivative of the product on the inside. So that's the r squared times h. So on this one here, I'm going to do 1d2. So 1, and then the derivative of the second, which is dh by dt, plus, so this is 1d2. And then I'm going to add to that 2d1. So 2, and then the derivative of 1, but with respect to time, dr by dt. And this is 2d1. Okay, and I'll just leave it like that. I would just plug my values in and tidy it up. Okay, so in your textbook, I get asked these questions a lot, so I just thought I would do them right up front in my lesson. So on page 145, number 1, there's this question here. It says if xy squared equals 12, dy by dt equals 6, find dx by dt when y equals 2. So basically, we're taking the derivative with respect to time, but now we're solving for something specific given some values. So I'm going to take the derivative with respect to time of xy squared equals 12. Okay, derivative with respect to time. So again, this is a product. So I do 1 and then d2, derivative of y with respect to time. That's 1d2 plus 2y squared d1. And that's just dx by dt. And that will equal to the derivative of a constant is 0. So at this point here, it looks a little bit ugly, but we're just going to substitute in the values that we know. Okay, so we know that y equals 2. Okay, so I've got, anytime I have a y, I'm going to substitute in 2. I know what dy by dt is, and I'm trying to find dx by dt. But it looks like I don't know what x is right away. So I'm going to have to do a little bit of work. If I know y equals 2, I can substitute that value in here and figure out what x is. So if I have xy squared, that's x times y squared, and I know that equals 12. So that means x times 4 equals 12. Divide both sides by 4, and I now know x is 3. So remember, there's only one thing that you're not allowed to know. So now I know everything except for dx by dt, which I'm trying to solve for. So I have x, which is 3, 2y, which is 2 times my y value, dy by dt, which is 6, plus y squared, times dx by dt, which is what I want, equal to 0. Okay, so now I just have to tidy this up. So here I have 3 times 2 times 2 times 6, that's 72 altogether, plus 2 squared is 4 dx by dt equals 0. So to get dx by dt by itself, I'm going to subtract 72 from both sides. So I have 4 times dx by dt equals negative 72, and then divide both sides by 4. So this is dx by dt equals to negative 72 divided by 4, negative 18. Okay, so I'm just taking that idea one step further, taking the derivative with respect to time and then substituting values in. Okay, let's try number 2. So if you want, you can pause the video, try this yourself, and then see if you get the same answer as I do. So I want to find dy by dt this time. If I'm given dx by dt is 4 and x equals 2. So again, I'm anticipating a problem. I'm probably going to have to find out what y is because there's only one thing I'm not allowed to know. So before I take the derivative, let's do that. So I've got x cubed plus y cubed equals 9. And I know x is 2, so that's 2 cubed plus y cubed equals 9. And 2 cubed is 8. So subtract 8 from both sides, and y cubed equals 1. Take the cube root, and now y is 1. So now I only have one thing that I don't know. So I want to take the derivative with respect to time of x cubed plus y cubed equals 9. So this will be 3x squared dx by dt plus 3y squared dy by dt equals the derivative of a constant is just 0. So now I just plug in everything that I'm given to solve for dy by dt. So 3x squared, that's 3 times 2 squared times dx by dt, which is 4, plus 3 times y squared, we found y was 1, and that's multiplied by dy by dt equals 0. So then I have 3 times 2 squared times 4. Altogether, that's 48, plus 1 squared is 1 times 3 dy by dt equals 0. So to get dy by dt by itself, I will subtract 48 from both sides. And then I will divide both sides by 3. So dy by dt is equal to negative 16. So this is just a little introduction to how to derive with respect to time, how to take the derivative and plug in for specific values. So I hope that this helped, and in the next video I'm going to start related rates by doing word problems.